Ladies and gentlemen, imagine a world shrouded in darkness, not because there is no light, but because there is no sight. Let's travel back 540 million years to a time when the world was a place of pure, endless darkness. Not a single eye existed to perceive the wonders of light filtering through the ocean depths or the glow from hydrothermal vents teeming with life. This ancient world was a place where light was meaningless because no creature could see it. But then, something miraculous happened. Trilobites, the first organisms capable of sensing light, emerged. They were pioneers, the first to experience a reality beyond themselves. This newfound ability to see sparked the Cambrian explosion, a period of rapid evolution and diversity in the animal kingdom. What began as a passive act, the mere reception of light, soon evolved into something much more profound. Sight became insight. Insight led to understanding. Understanding prompted action, and action gave rise to intelligence. Fast forward to today. We live in a world where natural visual intelligence isn't enough to satisfy our curiosity. We strive to create machines that can see and understand the world as we do, if not better. 9 years ago, I stood before you to share early progress in computer vision, a branch of artificial intelligence. We were just beginning to harness the power of neural networks, specialized hardware known as GPUs, and vast data sets like the 15 million images in ImageNet curated by my lab. These three elements converged to usher in the age of modern AI. Our journey has been remarkable. Back then, simply labeling images was a breakthrough. But today, our algorithms can do so much more. They can segment objects, predict dynamic relationships, and even describe photos in natural language. The speed and accuracy of these technologies have improved at an astonishing rate. I recall working with my brilliant former student, Andrei Karpathy, on an early computer vision algorithm that could describe photos. At the time, I asked him if we could reverse the process. Could we make computers generate images from descriptions? Andrei laughed and said it was impossible. Yet here we are today, with diffusion models that can turn text into images and videos. The impossible has become possible. You've seen the impressive results from tools like DALL-E by OpenAI. But even before that, my students and collaborators developed Walt, a generative video model. We are pushing the boundaries of what AI can achieve, though there is always room for improvement. Remember the cat in the wave? It didn't get wet. What a catastrophe. But if history is any indication, we will learn from these mistakes and build the future we dream of. In this future, AI will do more than just see and talk. It will act and learn. Seeing is for doing and learning. When we interact with the world in 3 dimensions, we gain deeper understanding. Nature created this virtuous cycle of seeing and doing, powered by spatial intelligence. This is the ability to perceive and understand the spatial relationships in our environment, linking perception with action. Imagine looking at a picture of a glass about to tip over. Instinctively, you want to reach out and catch it. This is your brain using spatial intelligence to predict what will happen next. This innate ability connects us with the world around us. Our goal is to imbue AI with this same spatial intelligence. Recent milestones are teaching computers to see, learn, and act in our 3-dimensional world. This is no easy feat. It took nature millions of years to evolve spatial intelligence. Yet just recently, researchers developed algorithms that can transform photos into 3D models. My team has gone further, creating algorithms that generate 3D shapes from a single image. We've even made strides in converting textual descriptions into 3D room layouts and generating infinite plausible spaces from a single image. These are the first signs of a future where our entire world can be translated into digital forms, rich with detail and nuance. As spatial intelligence technology advances, we are witnessing the birth of a new era. This progression is catalyzing robotic learning, enabling machines to understand and interact with the world as we do. A decade ago, ImageNet from my lab provided millions of high-quality photos to train computers to see. Today, we're using similar approaches to teach computers and robots how to act in the 3D world. Instead of static images, we create simulation environments where computers can explore infinite possibilities. This project, led by my lab and called Behavior, is just one example of our progress. We're also making exciting strides in robotic language intelligence. My students and collaborators have developed a robotic arm that can perform tasks based on verbal instructions, opening drawers, unplugging phones, even making sandwiches. While this is just the beginning, it's a promising start. Think back to that primordial ocean, the ability to see transformed life, triggering the Cambrian explosion of interactions and intelligence. Today, AI is on the brink of a similar revolution. Spatial intelligence allows machines to interact not only with each other, but with humans and both real and virtual 3D worlds. This will profoundly impact our lives. Consider healthcare. For the past decade, my lab has been applying AI to improve patient outcomes and reduce medical staff burnout. We've developed smart sensors to monitor hand hygiene, track surgical instruments, and alert care teams when patients are at risk. These ambient intelligence technologies act like extra pairs of eyes, making a significant difference. But we envision even more. Imagine autonomous robots delivering medical supplies, freeing caretakers to focus on patients. Augmented reality could guide surgeons through safer, faster, and less invasive procedures. Patients with severe paralysis could control robots with their thoughts, performing everyday tasks with the power of their minds. Recently, my lab showcased a robotic arm cooking a Japanese sukiyaki meal, controlled by brain signals collected through a non-invasive EEG cap. This is just a glimpse of what's possible. The emergence of vision transformed life on Earth, leading to the development of intelligence. AI's progress in the past decade is equally astounding. But to unlock its full potential, we must equip our machines with spatial intelligence, just as nature did for us. This is an exciting time to teach our digital companions to learn, reason, and interact with the 3D space we call home. Realizing this future requires thoughtful steps and a focus on putting humans at the center. If we do this right, AI will not only be a useful tool, but a trusted partner, enhancing our productivity and humanity while respecting our dignity and lifting our collective prosperity. What excites me most is a future where AI becomes more perceptive, insightful, and spatially aware. Together, we will embark on a quest to create a better world, constantly pursuing better ways to make a difference. Thank you.